Sometimes the question will not tell you whether to use a Mollier diagram or to use the tables. But the information that we have in front of you should be able to guide you that no, I don't think I'll be able to use the tables here because of 1, 2, 3, or I won't be able to use the Mollier diagram because of 1, 2, 3. So this is going to teach you. Let's read this question here. Let me increase the font. Increase this. Okay, right. Question 6. A combined separating and throttling calorimeters. This is what we have done already. Were used to determine the dryness fraction of the steam in the main pipeline under the pressure of 2,500. So P1 is 2,500. This is pressure before throttling. Do we need temperature before throttling? No, you don't need that. It is not important. We need it, but it's not important for our calculations. T1. The pressure and the temperature after throttling was P2 is 120 kPa. And T2 is 124.8 degrees Celsius. Okay? Now, respectively, 1.75 kg of steam was condensed. In other words, mass of steam is 1.75. MS, the mass of steam, is 1.75 kg. And then was condensed after choking. While after choking is after throttling. Sometimes they will say that calculate X after choking, which is the same as after throttling. So choking and throttling are the same thing. While 0.15 of water. So the mass of water that was collected from the separating calorimeter MW is 0.15. Can you see the difference between MS and MW? But if that MW increases, now it means there's something wrong with your boiler. There has to be really a significant difference between the mass of steam and the mass of water. So determine the dryness fraction of the steam in the separating calorimeter. Determine dryness fraction of steam in the 6.1 separating calorimeter. So 6.1, we say that 6.1, the question says calculate X1. X1 is mass of steam divided by mass of steam plus mass of water, which is 1.75 divided by 1.75 plus 0.515, and therefore X1 is equal to, I did some calculations somewhere to save time. Where are my calculations? I don't know where I put the calculations, but I can quickly 1.75 divided by 1.75 plus 0.15 plus bracket 0.921. So please, let's have our answers to 3 decimal places. 0.9921. It is not 0.92. Let's try to have 3 decimal places. So this is our X1. Perfect. Very easy. 2 marks or 1 mark. Now we move to the second one. 6.2 says determine the dryness fraction in the choking or throttling calorimeter, X2. And then we said that X2, that's where we said that H wet or H1 is equal to H2 or H soup. H wet is going to be HF plus X2 HFG, both at which pressure? At 2500 kPa, is equal to H soup at 120 kPa and 124.8 degrees Celsius. Let me explain H soup. There are three methods where you can determine H soup. The first method is by using a formula, but you only use a formula if Cp is given. The first method for H soup, the first one is the formula, where you say that H soup is equal to Hg plus Cp bracket T soup minus Ts. This is the first method that you can use. But we cannot use this method because there is no Cp. T soup is given is 124, but because there's no Cp, the first method is doomed. You can't use the first method. The second method is by using the tables. Tables, where you go to superheated steam tables. Superheated steam tables, you locate 120 and 124 degrees Celsius. Let's go to the steam tables under superheated steam tables and see if we can locate 120 and 124 and see if it's possible. Now we are going to the steam tables. Steam tables, you scroll down to superheated steam because the steam is superheated. And then the pressure is 120, 0.12. Where is 0.12? There is no 0.12, 0.1. It's 100 kPa here, it's 200 kPa here, there is no 120. And the temperature is 124. Temperature here is 150, and the temperature here as well is also 50. So it is impossible for us to use the tables because there's no 124, there's no temperature, and there's no temperature and there's no pressure. So the second method is out. Oh, sorry, where are we? We are here. Tables, that method is also out. It is not helpful at all. Now we go to the third one. The third one is Mollier diagram. Mollier diagram. We go to the Mollier diagram. The Mollier diagram is the only method that we can use. We are not going to get the same answer, but the final answer should be the first two numbers after decimal place must be the same. Otherwise, you know that you made a mistake with your Mollier diagram. So the first method, I think there are three methods. The first one we can use because Cp is not given. The second one is what? It's the tables. You can't use the tables because there's no temperature, there's no pressure on the superheated steam table. And then the last one now is what? Is the Mollier diagram. So the Mollier diagram, we have the pressure is 120 and the temperature is 124. Now let's go to the Mollier diagram. Go to the tables, and then you go to the Mollier diagrams, and then you locate 124. It's 124. Mollier diagram is 120 kPa. Where is 120? So you have 100 here. You have 100 kPa. You have 110, and then you have 120. Here's your 120. And then the temperature is 124. Let's say 125. 125 is 100, 110, 100 is 100, 110, 120. So 125 is somewhere here. So here is the intersection. Intersection, and then you take your ruler. We are looking for enthalpy. Enthalpy. According to me, to my graph, my enthalpy is 2720. 2720. This is my H soup based on 120 kPa and 125 degrees Celsius. And then you go back, you say that H soup here is 2720 kilojoules per kilogram. The question is, how do you know if your H soup is wrong from the Mollier diagram? You will see if your X2 is more than 1, you must know that this value is wrong. You must go back and try to be accurate. There's no way in which this X can be 1. It's supposed to be 0.9 or 8 something. So now let's compute this. HF at 2500 from the tables. HF at 2500. Let's go up. HF at 2500. Where is 2500? Here is HF. 96187. 96187. 96187. 961.87. Now let me change color. Nine six one 961.87 plus X2 HFG at 2500. 2500 HFG is 1840.1. 1840.1 is equal to H soup 2720. Okay, let's see. So it's 2720 minus 961.87 is equal to 1758 divided by 1840.1. Answer there is 0.955. So X2 is 0.955. So we have X2. Therefore, the last question, which is 6.3, it says calculate the dryness fraction in the main pipe. In other words, XO. So XO is equal to this value, 0.921 multiplied by 0.955. And the answer is 0.955 multiplied by 0.921. 0.87995. So you can see that XO is 0.88. You can say 0.88. And then there are no answers here. Why are there no answers here? Yeah, there's no answers. I don't know why they didn't give us answers. But in any case, our dryness fraction in that boiler is giving us 88% of vapor and only 12% of water. It is not, I won't say that it's the best boiler yet, but at least it's trying. If it was over 90%, then I'll be very happy. But it is not bad, but it's not good. So it's 88% of vapor and 12% of water. Okay. So this is question 6. Question 6 is different from question 5. Question 6 is different from question 5. Okay, let's have a look at question 5. Question 5, a combined separator throttle calorimeter is used for a dryness test. The pressure in the main supply is 680 kPa. In other words, that is 680 is what? It's your P1, and it's throttled to P2 150 and T2 170. During the test, 0.9 of water MW and 1.53 of condensate MS are accumulated. Calculate the degree of dryness in the separator. In other words, 5.1, they want X1, 5.2, X2, 5.3, X0. Okay. Why am I saying that 5 and 6? They are the same. The difference is that for you to calculate all the HFGs, you have to interpolate, because if you look at the steam tables, there's no 680 kPa. So you have to interpolate. The interpolation, some of the second year students, they still don't know how to interpolate. Some of the S2s or year 2 students, they still don't know how to interpolate. So let's start. We start with the first one. The first one is relatively easy. It's X1. X1 is equal to MS plus MW, which is 1.53 divided by, okay, you see what is happening. That's 0.9. It is really very close to 1.53. We will see what the answer is, but from where I see it, I don't like that 0.9. So let's see, 1.53 divided by 1.53 plus 0.9. 0.629. Can you see what I'm talking about? This 0.9 is producing, there's a lot of water, and I don't like it. So this boiler is giving us the dryness is 0.62296. 62%. The problem is here. It is we're producing way too much water. I said that the difference between this value and that value must be significant. So I'm not happy with the performance of this particular boiler or separator. In fact, the boiler, because ultimately it doesn't matter what our X2 is. Ultimately, the dryness fraction of the steam in the main pipe, it is still going to be 0.6 something. But you will see when we get there. Ultimately, I'm not looking forward to 0.7 or 0.8. It is still going to be 0.6 something. But let's first calculate the dryness fraction of steam in the throttling calorimeter, which is calorimeter. We will say that HF plus X2 HFG is equal to H sub. So HF and HFG at 680 kPa, and H sub at the temperature and pressure 150 kPa and 117 degrees Celsius. Okay, so let's first start with H sub from the Mollier diagram. H sub from the Mollier diagram at 150 and 170. Okay, so so this is 150 and 170. 150, where's 150? This is 100, 120, 140, and 150 is somewhere here. And then the temperature is 100 here, 110, 120, 117 is here. So the intersection is at that point, and I'll take a ruler. Take a ruler. No, sorry. I think 2720. That's me. You might get 2710 or 2730, but 2720 or 2710. Yeah, you can say the 2720 or 2710. Okay, so we have the first one. So we say that A soup is 2710 or 2720. So we say kilojoules per kilogram. Now here is the problem. We have to determine HF and HFG at 680. Let's go to the steam tables and check if we do have steam 680. Steam tables. Let's go up and 680. Here is 600, 650, and 700. Now we have to interpolate. Interpolate something that the students don't want to do, but we have to interpolate. So HF between 684 and 697. HFG between 2075 and 2065. We have to interpolate. So let's start with the first one. The first one, we calculate HF. So we say HF. This is a problem. I think I'll have to use a word instead of this thing. It's not cooperating. So we start with HF. We say that HF at 680 is going to be, I think what you need to do, you need to take this value, write this value down. So this value, you must write them down so that you don't go up and down to save time. Let's write the following values down. For HF, it's going to be 650. Then HF at 650 and 700. And then we have HF 684, 08, and then we have 697 at 700, 00, HFG at 650, it's 2075.5, and then we have 2065.8. Right. So let's go back. So here are the values that I got from the tables. So to interpolate, I'm not going to teach you. We are second year students, we know how to interpolate. Each student can use his own method as long as the answers are correct. So under 650, 650, and then 700, and then here we have got 680. So HF, it is 684.08, and then the 700, 697.00, and HFG is 2075.5, and then we have 2065.8. So our HF at 680 is going to be between 697 and 684. If it's not in between, it means that your HF is wrong or your method of interpolation is wrong. Similarly, with HFG is going to be between 2075 and 2065. Otherwise, the method we used is wrong. So I'm using my own method. where I say that HF is 680. I'm going to say 684,08 plus the difference between 697 minus 684,08 divided by 700 minus 650 multiplied by the difference between 680 and 650. Okay, so where is my answer? My HF at 680. Guys, remember, you don't get even 1 mark for the correct answer for interpolation. I don't give marks for that because this is not second year stuff. So my answer here is 691,832 kilojoules per kilogram. This is for my HF. Now we have to do the same thing with HFG. HFG at 680 is going to be 2075 plus the difference between 2065, 8 minus 2075, 5 divided by 700 minus 650 multiplied by 680 minus 650, and the answer is 2069, 68 kilojoules per kilogram. So HFG is 2069,68. HFG 691,832. You can see from my values here that 691 is between 684 and 697. 2069 is between 2075 and 2065. So my answers should be correct. Now we can substitute and get the value of X. HF, we say 691, 832 plus X2, 2069,8. Bracket, we said our H soup is 2010, 2710 or 2720. 2710 or 2720. And then what is the answer? We say that 2710 minus 691,832, 2018. So it's 2018 X2 divided by 2069,8. So X2 is divided by 2069.8, 0,975, 0,975. That is our X2. So X0 is X1, which is 0,6296. 6296 multiplied by 0,975. So multiply by 0,6296. So look how poor this boiler is. Look how poor this boiler is. 614. So the boiler is giving us just 61% of vapor and the rest is water. You can't be happy as an engineer if you get something like this. There's a red flag here. There's a red flag here. So there's something wrong. And something wrong, if you have to investigate, it means that the boiler is releasing more water before it's evaporated. So the problem is actually here. If you make this 0.2, then this is going to improve, or you increase this value, or either you increase that value or you decrease that value, one of the two. But you can never be happy with a dryness fraction of your boiler being 0.6 something. It's completely poor. I don't like it. Okay. So the last one, I can feel now I'm tired. The last one is question 4. So you will do question 3, question 2, and question 1 as homework if you want to, but I'm not going to mark it. It's for your own good. Let's have a look at question 4. Question 4 is also different from question 5 and question 5 and 6. Now, question 5 and 6. The question never said anything about the atmospheric conditions. But in actual fact, when we do an experiment, we have to consider atmospheric conditions. In other words, atmospheric pressure. And then we don't use gauge pressures, we use absolute pressures. But for question 5 and 6, because we are not given atmospheric conditions, that's why we used gauge pressures. So question 4 changes that scenario. It gives us atmospheric conditions. In other words, your P1 must be absolute. Your P2 must also be absolute. Let's read the question. The question says, steam is throttled in a calorimeter under a pressure of 900. This is gauge pressure, P1 gauge. Manometer reading was 70 millimeter mercury. Manometer reading is what? Is P2 gauge pressure. So P1 is 900 gauge pressure. P2 is 70 millimeters of mercury gauge pressure. Now the atmospheric pressure from the barometer is 760 millimeters of mercury. And the temperature of steam after throttling is 120. Determine the initial dryness fraction of steam. So we can see here we are not given information on separating calorimeters. So X1 we won't be able to calculate. What we are going to calculate here is X2. That's what they are looking for because there's no X1. So X2, we know that X2 is equal to HF plus X HFG is equal to H sub. First of all, let's calculate P1 absolute, P2 absolute. So P1 absolute is going to be 900 kPa, which is gauge pressure, plus 70, which is mercury, divided by 7.5. Or if you don't want to use this method here, you can use the long method because you know that pressure is equal to what? Is equal to is rho G by H. So for me, I took a shortcut by saying 70 divided, this is 70 of mercury divided by 7.5, which is the same as rho for mercury is 13.3 multiplied by 9.81 multiplied by height, which is 0.07. So the answer we get from here and the answer we get from here are the same. So P2, you do the same thing. You can say P2 is going to be 760, which is atmospheric pressure, plus 70 gauge pressure divided by 7.5. You get you get the pressure. So let's see, 70 divided by 7.5 plus I think, you know what, I want to avoid a confusion here. Otherwise, we are going to have a lot of different answers at the end of the day. Multiply by 0.007. Okay, so I want us to use only one method. This thing of shortcuts, it's not time for me to introduce shortcut now. Okay, so let's just forget about this one for now. This shortcut thing does not work. Okay, so we will say that plus bracket 13.3 multiplied by 9.81 multiplied by this P1 0.76. Remember, this 76 is atmospheric for both, so you use it when it comes with P1 and P2. So 0.76 multiplied by 9.81 multiplied by 13.3, 99. So 99 plus 900 is 100. So P1 is going to be 900 plus 100 plus 100, 1000. So your P1 is 1000 kPa. P2, we are going to say that 13.3 by 9.81 bracket 0.76 plus 0.07. The answer is, you can separate them if you want to say that P1 plus P2, but this is atmospheric, this is the gauge pressure, this is the rho, this is the G, and then you get your answer. So it is 0.76 multiplied by 0.07 by 9.81 by 13.3. 6.9. It can be. There's a mistake here. There is a mistake here. 760 plus 70 is equal to divided by 7.5. 110. 110.67 kPa. But for making things easy, you can say that P2 is 110 kPa. So where we are, ladies and gentlemen, I think now we are almost done with what we want to do, because it's easy now to get HF at 1000. We do have HF at 1000 from the steam tables. We do have HFG at 1000 from the steam tables. And then we can say H soup at 110 and 120 degrees Celsius from the Mollier diagram. So now you know how to use the Mollier diagram. You know how to get this temperature. I'm tired. I can finish it, but I feel like I'm tired now. HF at 1000. Let's go to check HF at 1000. HF at 1000 is HF at 1000 762.51. It is 762.51. 762.51 plus X HFG. HFG at 1000 is 2014.6. 2014.6. 2014.6 is equal to H soup. Guys, I'll give you 2 minutes. I want you to go to Mollier diagram. Give me a soup at 110 and 120, please. And then you write your answers on the chart. H soup at 110, kPa at 120 degrees Celsius. Please, 2 minutes, you write your answers on the chart. I'll also check from my side which one is the correct answer. 2 minutes. So okay, I'm back, and I'm happy that most of you have got the same answer. My answer is 2720. Let's check. Let me quickly share with you. I also got 2720, and let's see how we got that 2720. So majority got 2720. There we go. It's 120 there, it's 110 there, and then I got 2720. Perfect. So I'm happy that at least we see things the same way. So we have 2720. 2720. Therefore, our x in this case is equal to 0.97972. Okay, so the answer that we have here is 0.975. So never mind about that 5. The most important values are those 9 and 7. These are the most important ones. So 9.72 is the correct answer. I give you full marks for that. And question 3, 2, and 1, if you understand the last 3 questions, you should be able to